Hello everyone, welcome to Decoding. In the previous video, another method or another approach by which we can solve our two-sum problem. But at the very start, I am telling you this is not the most efficient, or you can say in terms of algorithm, this is not the optimal approach. It is an approach to build your intuition on how you can think and how DSA, that is the data structures and algorithms, wants you to think in different aspects and different dimensions. Like you can see, I have written here the brute force approach that we had applied in the problem while solving it in the previous video. We calculated the length here, we ran a for loop, and inside that we again ran a for loop, which was causing it to reach the time complexity of order of n square. And you already know that why it was reaching to n square, because it was being run to n and it was dependent on this, which was literally to approximately running till n, then n is to n gives you n square. That is the time complexity it was giving us. So we talked about this previously, but today I am going to bring something new, something like in terms of sorting. If you know what does sorting means, please write in the comment section. For those who does not know anything about sorting, it is simple in terms of, you can say, ascending order or descending order. You have studied in your elementary education how to put numbers into ascending or descending order. Sorting is the exact thing. So what we are using today is sorting approach, and plus with sorting we will be using something like pointers. I will be coming to the solution right next after this page, but let me first take an example. We took an example of 2, 7, 11 and 15. This was our previous example, or the very first test case of the lead code, 2, 7, 11 and 15, and we had been given the target value as 9. We already know that as we have solved it. Target value was 9 and we knew already that 2 plus 7 will give us 9. But we are not applying the brute force approach, we are doing something else. First of all, the approach should be like, let me give you the intuition first. What we will be doing is that we will create a pair with their indices. What I am saying is that create a pair with their index value, or the location they are present at. So 2 was present at 0th location, 7 was at 1st, 11 was at 2nd, and 15 was at the 3rd location. Yeah, 3rd location. So this is the index, and these are the values. I hope you get my point. So we are creating the pair with the indices. How can we do this? We can create like 2 is on the index 0. Now 7 is on the index 1, and 11 is on the index 2nd, and 15 is on the index 3rd. Then after we will apply sorting. So in this scenario, the values are already sorted, like 2, 7, 11 and 15 are already being sorted in the ascending order. So here we do not need the sorted thing, but I will explain you with another example, like, or we can consider having 7 at somewhere and 15 at somewhere. Let me give you a glimpse what I am trying to say. That, yeah, so 7 supposing is at 3rd location, so it will be here, and 15 is at the 1st location in the array, it will be here with its index. Alright, we had created the pair with the indices. Now coming towards applying the sorting. If we apply sorting, we will get like this: 2, 0, then 11, I'm sorry about that, 7, 3, 11, 2 and 15, 1. If you see, we have sorted the values like 2, 7, 11 and 15. We have sorted the values. Now in this pair we have the sorted pair, like I can say it by the name as num of index or something like that. Like you can say num of index, yeah, or sorted you can say. So nums of index, nums with index, we have the value of, we have the number, we have its original index also, like 2 was at 0th location and 15 was at first location. We already know in the array, you can see it here. So we had the nums with index array which is already sorted. Now let us create two pointers. Let us create two pointers. What does pointer stand for? I already told you in the previous video. If you have not seen it, please watch it, then only you will understand what we are doing here. So the two pointer approach says that create one left pointer here and one right pointer at this location. What I'm saying is that in this array of sorted elements with their index value, create two pointer where left is at the very left end of the array and right is at the very end of that array, the rightmost part. I hope you got this. We have created two pointer also. Till now we have created a pair with indexes, and then we have applied sorting, and then we have created two pointers which were locating at the left side and the right side. Now these two pointers, we will be making them come inwards. We will be making them come inwards and we will test them. Let me give you the solution what we are doing. We have created a variable, suppose sum or target sum. We can say target sum, or let's make it simple. Yeah, we have the array value as sum. Now my left pointer is at left side and current right pointer is at the rightmost side. If I see left value, so left value is 2, and if I see right value is 15. What I get here is 17, and I match it with my target. Is it equal to my target? Target was 9, so target was 9, which was false. So if it is false, then we get to know that it is 17, right? It is 17 and it is not equal to 9. Or you can let me make it more simple to you, as it is 17 but this 17 is greater than 9. You can say that the sum is too high. The sum is too high. So if it is too high, then I think my right pointer is at the wrong location. Then I get to reduce right by 1. Reduce right by 1. So right pointer dislocates from here and come to this part. Now simple, because it is too high. Why I am not messing up with the left pointer? Because it is not low, it is high. Understand? When you will be doing the binary search, you will get to understand this pattern more, and that is why I am putting it here in the very second video of the playlist. Now coming towards again, because it didn't match with our solution. Left pointer was 2 but right pointer came to 11, and this 2 plus 11 gave us 13. Once again it is 9 and it is too high. Once again right value will be reduced to 1. This right pointer comes toward here. Now if I calculate this sum, once again the left value was 2 because we hadn't changed the pointing location of the left pointer, but the right value consists now 7. Right pointer is pointing to the 7, which has the original location of 3, already know. Now 2 plus 7 gives you 9, which is definitely equal to 9, and when it is equal, we exit. We got the answer. Why we got the answer? Because this 2 had its original location as 0, 0, and this 7 has its original location as 3. So 0, 3 will be our answer. And if you see in the array, 2 was at 0th location and 7 was at third location, so our answer location should be 0, 3 to match up the target value when they were added together. I hope you got this solution, you understood it. Let us take one more example so that you get to understand it better. Let me create an example right here so that you understand better what we are doing. We have an array, suppose 3, 7, 9, 4 and 5. Alright. Now in this array, we know this array has locations. Like to make it simple, let's give 0, 1, 2, 3, 4. This 3 is on the 0th location of the array, 7 is on the first location of the array, and 9 is on the second location, 4 is on the third location, and 5 is on the fourth location. Now if I see that I have to follow the algorithm. What algorithm says that pair with the indices. I have to create pair with their respective indices. So pair with their respective indices means that this 3 comes with 0, this 7 comes with 1, this 9 comes with 2, and this 4 comes with 3, and this 5 comes with 4. Alright, we have the pair with the indices. Now the second approach, the second step was to sort them out. So how do we sort them? It's simple. We apply the sorting technique, or we use the direct function, sort function, in the Python or any other language, because we are not making the algorithm of sorting here. We are using that sorting which is already been implemented in some other algorithm. So yes, let us sort it. So the smallest value here is 3 already, so 3, 0, then comes 4, 3, then comes 5, 4, then comes 7, 1, then comes 9, 2, and we hadn't put the target value here. Let us give it a target value of 3, 8. Let us give it the target value as 8, so that 3 added to 5 gives us 8. Alright, we are here now at the sorted part. Now the last thing is apply to pointer. Applying to pointer is that the left and the right, and I'm not making it here like this. The left pointer, it already has the location as 0, it already has the location as 1, it already has the location as 2. So do not mess up with the previous concepts. Alright, they have some locations, so right and left are pointing to some memory locations. Alright, so this left, we are creating the variable as sum. Now this sum is tested. Bro, what is the left value? Left value is 3. What is the right value? Right value is 9. 3 plus 9 is giving me 12, which is too high as compared to 8. So I reduce my right value from here to 1 less than. So I come at here. Now coming to, so I can say like right minus minus, I am reducing by 1. Alright, I think you got it. Now the sum value comes at here, and we have not changed the left value at it, that is 3 plus 7, and this 3 plus 7 is giving us 10, which is already greater than 8. So once again right is being reduced. When I come towards, the sum equals to 3 plus, right is reduced, 3 plus 5. Now this 3 plus 5 is giving us 8, which is already equal to 8. So we exit here, and by being exited, what we are returning? We are returning their respective indices. So 3 was added, which had the location as 0. 5 was added, which had the location as 4. So 0, 4 should be our answer. And if you see this, 0, 4 will give us answer, which is the matching the target value as summing them up. Alright, so I hope you got the solution, but as I am already saying that this is not the exact solution. We should focus during the interviews, because this is the solution which is helping you to build your intuition. Like, we should not always think in terms of brute force and the most optimal thing, because in the interview also we might not be able to think the most optimal thing right there. So you can think in terms of sorting, you can think in terms of other patterns that might bring us to that solution, or it might bring the intuition so that we can further move towards the optimal solution, right? So now let us come towards the solution. What I did here, I will be explaining you right afterwards. This was already stated in the function of the lead code problem. So we are using the sorting plus two-pointer approach. Very well. Let us focus towards what we did here. So we use the enumerate keyword, and here we have been doing this simple thing is that we are creating the number with their index value. We are creating the pair of the numbers with their index value. So this num with index, num with idx means index, doesn't mean much. It only says that we are creating the pair of the numbers with their index value, like we did 3, 0 and 7, 1. This one, the approach that we followed. All right, I hope you got this line of Python code. Now in the second thing, so we created here pair, step 1. Step 2 was we should do sorting, and definitely we use dot sort here. In the second line we used dot sort. This dot sort approach simply says that you are applying the most okayish, or you can say the most optimal sorting technique, which gives you somewhat log n of time complexity or something like that. You will be doing that. All right, now coming towards the left pointer, we stated the left, we initialized left and right to 0, and then this was the length of nums with index -1. The right had the rightmost value and the left has the leftmost location, like it is something like 0 to, you can say, n-1, right? So this was this, we are creating here right and we are creating here left. You got this. Now we are again running the loop while left is less than right. So left is less than right, which means we haven't exhausted our array. Until left is less than right, we haven't exhausted our array. What I'm saying is that until left is less than right, which means in this scenario right is coming in the left of left. All right, so this means that the right has iterated till the very end and crossed left also. That means the array has been exhausted, the pair has been exhausted, and there is no solution. Then we return the empty array. Simple as that. Now coming towards the logic, what we are saying is that current sum. Now your current sum, if your current sum is left having the 0th location as it was having the 0th, right? No, this is not the thing that we are doing here. We are doing here is left 0. What does this say? Nums with index left comma left 0. So this left 0 says that we have at the left is the left comma 0 gives us this. This is also 0 comma 1. This is also 0 comma 1, right? So if you see, it is something like this. So it has the left as the value, and the at the 0th location it contains the pair. So it is something like 0 comma 3. So it is the you can say it is the location and it is the value. So it brings the location and the value. So this current sum is added to the this complete brings. What does this complete thing brings? It brings us 3 in this scenario. If it is 3 here, this complete thing brings us 15 or something 9 here. For this array it was 9. So right now we have 3 plus 9. We check this, we check our sum, is this equal to target, and we return the index of the left and index of the right. But you know what it is saying? 1 means the index. We have the index at the first location. All right, so we bring the index, but the 0th location contains the value and the first location contains the index in that particular pair. So we return that. If that is not the thing, then if your current sum is less than target, which is here it was greater, so it was greater, then it is running the else loop. So we are reducing, we always reduced right to one place to the backwards. So now coming towards, if somewhere arises a situation like current sum is less than the target, then we increase the left pointer, like we cut the left pointer from here and put it here, right? So this was the solution to sorting plus two pointer approach. Now let me once again explain you what these things stands for. I had created example solution. So what nums with index was doing is that num comma I for I, num in enumerate nums. So it was creating the pair with the indices, pair values with the indices. So if we take the example as 2, 7, 11 and 15, so nums with index, this particular code was just doing this thing: 2 with location 0, 7 with location 1, 11 with location 2 and 15 with location 3. So if I say this line, you will understand it better. This keeps track of original indices, and we need that because we are making something like memory, not exactly memory, but we are making something. We know the exact location, we know the original indices, and after sorting we know that indices. Now once again, current sum was doing this. So what it is saying, that it takes the values first element 0 in each tuple. So we have these tuples here, 3, 0, 4, 3. So the first is the value, second is the location. First is the value, second is the location. So it takes the value from the tuples. So tuples, first first location contains the value, and second location contains the let me say it is the memory location, that the original indices or the original memory location the array elements were stored at. Now we were comparing, left was 0, right was 3, so it adds up to 2 plus 15 definitely. Now if we say this code, so nums with index left 1, so you definitely know if 0 contains the value, then 1 contains the indices of that value. So return the original indices. We are returning the original indices. If we get the answer or we match up to the target location, then the second element 1 is in each tuple is containing the original indices of the two numbers that make the target sum, that are making the target sum. So supposing that 2, 0, 2, so this is 2 is at 0th location and 15 is at 3rd location, so we get the answer as 0, 3. This video has created your intuition that not every problem we should think directly about the optimal solution. We should put our hands in different directions and see what comes out. So if I come towards the time complexity of this solution, let us think in terms of what we were doing. We were creating pair with their indices, right? We were creating pair with their indices. I'm sorry with my inclination. So we were creating pair with their indices. So these pair with their indices were being created in I can say being scanned. The array was scanned for n times, like all the pairs were created till n, so order of n times the scanning will be created. Now let me once again tell you, the second thing was sorting. I'm sorry about that. I told you that sorting is order of log n. No, the most in the worst case scenario, sorting gives you order of n log n, right? So two things were being carried out, and the third thing was like creating the sum variable which doesn't adds up to the time complexity merge, creating the left variable and right left pointer and the right pointer which doesn't add up to the merge, and all these things we were doing were just searching out from the already existing pairs. So now if we think in terms of these two parts, what we were doing is that order of n and plus n log n, pairing and sorting. So this pairing and sorting, why we are doing it independently, because it was doing the pairing, and at the second time it was doing the sorting. So we have, and you should be aware about that, we haven't included here multiplication. We should because these two things are running independently. First we are doing the pairing, then second we are making the sorting from that pair. So all these two things are independent and they are added like order of n and added with order of n log n. So they give us the time complexity as order of the most which is the highest one, it is the highest one. So overall, comparing to the overall time complexity, we get it as order of n log n. And as per our previous video, we carried out as the time complexity in the brute force approach as order of n square. And if you compare it with current time complexity that we are getting here in the worst case scenario also, we are getting it here as order of n log n, order of n log n. So definitely this one was better, this approach was better, but not the best. I am again saying this approach was better but not the best. So we have done two things: brute force We have created the brute force approach of the two sum problem, which carried out to order of n square time complexity. Then we done something like sorting plus two pointer, which brought us to order of n log n of time complexity. These two things we have done. Now the last thing that we can do is HashMap. Also we can do binary search also, then sorting. You can think in that terms also, but that doesn't give us index. That defeats the whole thinking process. We should get the answer in terms of index value. So binary search will not work out here. We will be solving by these two things, and the most optimal thing is this. Optimal approach is using the HashMap, or you can say something like dictionary, HashMap or dictionary. So if I come towards this approach of dictionary, which I will be explaining you in the next video, I want you to think what we have arrived at. See what brute force was saying to us: fix one, then search for rest, or you can say scan rest. Fix one, then search for rest. Like, create all the possible pairs. This is the mental map that we can think in terms of that. This is the mental map. What brute force was saying to you: fix one, then scan all the possible results of that particular thing that has been fixed. Now this sorting and two pointer approach, it is saying that sort by value, then slide two pointers. We had created two pointers simply, then slide those two pointers inwards, to meet the target. And simply if that target is in match, we means that we have exhausted our pointers, we have exhausted our array, and we return the empty array. Now what will HashMap say? HashMap say, because it is a memory oriented solution, so it will definitely remember something. What we will be saying, that remember while scanning. We were not doing in that brute force approach. We were just going into the universe and making all the possible pairs. But this HashMap approach has brought us to think in terms of this: remember while scanning, and do not do this not searching. We are not remembering it while searching. We already know while scanning we just get the values. I will be coming towards this in more simple manner in the next video. Till then, I think you might have got what I wanted to share with you in this video. Let me give you a complete glimpse and complete overall gist what I told you today. So we had the brute force approach already, which was making us the time complexity of order of n square. Then I came towards with a solution of sorting, and we created three lines of algorithm. Like, we first create the pair with the indices of that array, like pair of the respective indices, then apply the sorting technique, and then third part was two pointer and match it up with your sum value. If you get the sum equal to target, then you have the solution existing in the array. If you do not, then you should return the empty array. Then I gave you the solution. You can put it in the lead code, you can solve it. Definitely you will get time complexity lesser than that, but you will fail in the optimality. So this optimality part we will be bringing in the next video, which is our HashMap, the dictionary, the best solution approach to solve this two pointer two-sum problem. To solve this two-sum problem, the best approach is HashMap. Now I will be sharing with you, and when I will be sharing with you HashMap, you will definitely understand it with crystal clear clarity, that why we are using HashMap at the first. Because you now know the brute force approach, you have implemented the sorting and two-pointer approach, but this is the most optimal approach that you can implement is the HashMap or dictionary in terms of Python. You can use it to solve this two-pointer, or so I'm really sorry once again, two-sum problem. So let us give you the solution, or let me complete the solution in the lead code, then you will get to understand what we were doing. Here is the solution. If you see, it is nums with index as the num I for I. We are matching up the pairs and then enumerating it into the pair value, pair index value. Now nums with index dot sort, we are sorting, putting the sorting logic here. It is the, the implementation is hidden. Now left right equals to 0, and the n-1, like something you can say that it is the last location of the array nums with idx. Now while left was less than right, we are iterating, we are creating the while loop inside, and inside the while loop we are checking that if the current sum is getting with the value of the left, where the left pointer is pointing, and the value where the right pointer is pointing. We are matching up that, and if we are getting the current sum equals to target, we return that index value from this one, because at the first location of each tuple we have the index value. Now if the current sum is less than target, simply we are putting left plus equals to 1. We are moving one step left to the right location. Now if if nothing goes good, which means the else statement, which means the current statement is greater than the target, then our right should be one step behind. Now if nothing works out, we return the empty array, and if I run this, I hope we get our test cases passed, and yeah, we have passed our test cases. If I submit it here, definitely I have already submitted. 36.52% people we have beat it out. Okay, 37.18 it got, and it has passed 63 out of 63 test cases. But let me once again tell you, it is memory efficient, but in terms of time complexity, nothing works out, because that thing is not the most optimal approach we can use to solve this problem. So I hope you get the point. I will bring the next video with the optimal solution. Till then, keep searching for that solution. Bring something from your inside and from your own brain. Think of the solution, or search on the Google and solve it using the most optimal approach, which is the dictionary based. Till now, signing off, decoding.